All right, at the top of page 2 of our notes, we're moving on to the second topic of this video, accuracy versus precision. Okay, now in non-chemistry class life, okay, we're in chemistry, so there's a difference between accuracy and precision. But sometimes accuracy and precision, these guys are thrown around in everyday life, kind of like they mean the same thing. Very similar to the way mass and weight is thrown around as if it's the same thing. Accuracy and precision are actually different, okay? So accuracy is defined as how well a measurement agrees with the true value. Precision, on the other hand, is how well a series of measurements agree with each other. Who cares about what the true value is? Okay, so precision has nothing to do with accuracy because we don't care about the true value. We only care about how well do our measurements kind of relate to each other. All right, so we're going to examine 4 situations. I'm going to use a dartboard analogy, and because we have 4 situations, we're going to have to draw 4 dartboards. I'm going to have to draw 4 dartboards. All right, dartboard analogy. So the dart is going to represent the result of a measurement, okay? Or the result of an experiment. That's what your dart is going to represent. And I will show darts by drawing a little X, okay? Now, the bullseye represents the true value. All right? So, dashboard analogy, let me just read it again from the top at regular speed. A dart represents the results of a measurement or experiment. The bullseye is going to represent the true value or the accepted value or the literature value of the measurement or experiment, okay? All right, so dartboard number 1 on the far left, I've got 5 darts. That means I've done 5 measurements or 5 experiments or 5 trials, if you will. Now, the darts are all over the place, okay? Terrible. So it's not accurate and it's not precise. We have errors wherever you can imagine we have them. So we have large random errors, in other words, poor human technique, okay? We may or may not have systematic error, but we can't pinpoint whether we do or not in this situation. Now, take a look at dartboard number 2. All 5 darts means all 5 experiments, all 5 measurements, whatever they represent, are right on top of each other. So we're precise. So we have good technique, no human errors, no random errors, okay? But we're nowhere near the bullseye. So the results that we're getting every single time are precise, but they're not accurate. If we're not accurate, we have large systematic errors. We have an instrumentation error. Something is wrong with our instrument or our glassware, okay? Now look at the one on the far right it's very obvious. We're precise, we're accurate. We've got no human error, no random error, right? And then we also have no systematic error, no instrumentation error. Now, I told you we'd be doing 4 analogies. We've only seen 3. Here comes the 4th one. 4th dartboard coming up. It says, hey, is it possible to be accurate without being precise? I see this question asked all the time on quizzes and tests, so I thought I'd put it here. Here's my 4th dartboard. And how am I going to draw this so I'm accurate without being precise? Well, I said we had 5 experiments or measurements. There's my 5 darts. 1 dart's a bullseye. And the average of the 5 darts is also the bullseye, right? The average of the 5 measurements or 5 experiments or 5 trials or 5 whatevers ends up being the bullseye. So we're not precise because the darts are not all on top of each other, okay? So we have no precision, which means we have a lot of human error, but we're accurate, all right? So this is accuracy without precision, okay? Very uncommon, but it does exist. All right, that little swervy line means I'm kind of moving to an example, and here it is. It says, a student performed an analysis. So this student could be you, could be the student next to you, doesn't matter, but it's a student in a lab performing an analysis of a sample for its calcium content. And this student got the following results. Now there's 4 results, which means the student has done the experiment 4 different times. And the results were 14.92% calcium, 14.91% calcium the second time around, third trial 14.88% calcium, and then 14.91% calcium. So just by eyeballing that, we can kind of get an idea if this is precise or not, but we can't eyeball if he's accurate. To be accurate, you have to know what the true value is, and it says that right here. The actual amount of calcium, by the way, in the sample is 16.25%. What conclusion can you draw about the accuracy and precision? Well, that row of results, all starting with 14, high 14s, okay? He's precise, so he's not making any human error. Okay, there's no random errors here. So he's precise, but he's not accurate. He's not getting anywhere near 16.25% calcium. So he's not accurate. So something is wrong with the process. Something is wrong with the way he's doing these experiments every single time. Okay? So we have systematic errors. All right? Systematic errors are occurring.